Hey, thanks for joining this workshop. I thought I would begin by giving you a very quick overview of where to get the documentation and where to find the workshop and the prerequisites that you'll need to build and run the workshop. So you should each have a username. So we'll have environment inside of OpenShift. We'll cover what that looks like in just a second. First of all, in my GitHub repo, Jeremy R. Davis J4K workshop contains all the docs, including links to everything you might need to download if you don't have some of this on your system. Like you'll need a JDK, you will need Docker if you want for some of the work exercises. Labs 2 and 3, you'll need Docker installed. If you need a Java IDE, got some links to all of those. So everything you'll need to get started, you can find in the workshop documentation. I also have a solution at my GitHub, Jeremy R. Davis, J4K-workshop-solution. I would recommend that you clone this file. So what I would do, for instance, let's see, I would put a folder on my desktop. On a Mac, desktop is fine. Windows, you might want to just do straight on the C drive, right? However you want to do that, doesn't really matter. J4K. And then inside of that, I would clone, let's go back and get this, right? I would clone this folder. So let's say, on my desktop, let's go into my folder, J4K. And then clone the workshop solution. So when you see the workshop solution, if you go into there, we'll notice git tag. I've got 4 different tags. These correspond to the steps in the workshop. So if you want to see the solution for step 1, right? Git checkout step 01. And you now have the complete solution for step 1. Right. So if you're done with that and you're ready to move on to step 2, just say git checkout step 2. And then you've got the completed solution for step 2. So you can just pull this down and work along with it. What I would do, we're going to create a brand new project from scratch. What I would do then is pull both of these into my IDE. So for instance, if you're using Visual Studio Code, you can just open Visual Studio Code in this directory. We'll clone the other one into here, and you'll have both of those will appear over here as solutions. I'll use IntelliJ for a lot of this. IntelliJ, I'll create a project and import 2 different modules. But that's what you need to follow along with this. Also, feel free to ask questions, and then you can pause this video along the way. The idea is that you can, get your setup going on. I'll then walk through doing some of the steps to build the workshop, and you can follow along. All right, thank you. All right, thanks for joining this workshop. So in this workshop, we are going to be adding a new microservice into the Quarkus coffee shop application. So this is the application, pretty simple for a coffee shop, right? We come in and we place orders. So I will get a black coffee. That gets sent from the website into a core microservice that takes the command that comes in. Later we'll build an order in command. It takes that command, it creates events from that command. In this case, the events are a beverage in event because I ordered a coffee. I didn't order any kitchen items, right? So it's going to create a beverage in event. That event will be pushed onto a Kafka topic. It will be picked up by our barista who makes all the drinks. The barista is going to grab that, apply some business logic, which in our case is really just an amount of time to wait before it creates a new event, which will be a beverage up event. We use the terminology up because in the restaurant industry, that's how you say something's ready. And that gets back to a bit about domain driven design that we talk about in our other presentation, but we won't talk about a whole lot here. We'll talk about it a little bit. So once that beverage up event is picked up from the same topic by the core microservice, the core microservice then sends an update into the web to tell us that it's ready. We then have some JavaScript that mimics somebody walking up to the counter, grabbing their beverage and clearing the counter off. All right, so that is a quick introduction into the application. If you have already logged into OpenShift, you should see your topology here. These little icons down here, you can shrink that down to see everything or expand it to investigate. We've got MongoDB running in here. We have Kafka running in here. It's based on the AMQ Streams build of Kafka, and we've got a number of different microservices. You can pull all these up, play around in the console some. This, for instance, we can click on our web microservice and immediately, those are some JavaScript errors that occasionally happen with timeouts to the front end. We're using server sent events to push those across. And it's not anything to worry about. You can play around in here and check out various pieces of the application. So we should see, for instance, let's drag this around inside of our core application. There we go. We can see create order events coming in, right? And we received an order up. So you can watch things stream through the logs as you build out your application. All right, now that's a nice quick overview. So let's get started building our application. First thing, we're going to integrate with this. We are going to integrate with the Fave food delivery service. Delivery is obviously an incredibly important part of the restaurant industry this year, as it never has been before. So Fave Food Delivery Service has given us a specification, an open API spec. They want us to stand up an endpoint where they can post this JSON format to us. We'll take that format, translate it, and then use the microprofile REST client to send it over to our existing web application. Later steps of this application, we'll swap that out and talk directly to Kafka, and we'll add in persistence so that we store the incoming messages inside of MongoDB. So let's get started here. We will go over to code.quarkus.io. Let's name our project J4K Coffee Shop. And J4K Coffee Shop Workshop. And we'll pick some extensions here. So Quarkus is really tiny runtime, but it uses extensions for its functionality. So we're going to be doing REST. So we'll grab JAX-RS. We'll grab JSON, REST-easy JSON-B for marshaling to JSON and the REST client JSON-B. Now we could download this application as zip, but we will push it to GitHub. And we're doing our Supersonic Subatomic push to GitHub. This will appear in my Git repo. Here are my repositories, right? And there's our Git repo with our application in it. So let's get this clone here. Okay. I'm going to put this in my folder. So I've got, just so you can see here, I've already got my solution in place, and I'm going to clone the one we just created. My solution is there so I can cheat. And I'm going to use IntelliJ. Feel free to use whatever IDE you want. There's some nice Quarkus functionality inside of IntelliJ. Red Hat builds out the Java plugin and Quarkus plugin for code-ready workspaces. Eclipse doesn't really matter what you want to use here. So we will go Coffee Shop Workshop is our new module. Yep, it's a Maven project. Apply and OK. All right. So we've got a very basic Maven application, right? If you've ever used Maven, you are definitely familiar with this. And we'll look at a couple of things we have here. So let's pop open a terminal. You can use an external terminal. CD J4K Coffee Shop Workshop. Let's go ahead and fire Quarkus up and take a look at what we've got. Clean compile, and we'll type Quarkus dev. So now this is going to download everything, compile everything. It's a little bit slower on startup, so we got that compiled, and we are now running. So let's come here to localhost. Let's go. Whoops, it's pretty big. So that's localhost 8080. Now, we have a REST endpoint that is already built in the application. Let's look at our example resource here, and it tells us. You can see here. This tells us /RESTEasy/hello, right? And it's just going to return hello. So let's go to /RESTEasy/hello. And that gives us hello. Let's expand that so we can see it. So that says hello, which is nice, right? But that's not super nice. So let's say hello J4K and see how that looks. Yeah, it looks okay. Let's get an exclamation point there. Okay, it's getting there, right? Save that. And fresh. Hello, J4K. All right, that looks pretty, oh, we need J, that looks pretty good, right? So we've got a decent message now. So that feedback loop is really nice and tight, right? As fast as I save this, the Quarkus is watching in dev mode. It watches, it's already recompiled and already loaded that class up into the browser, right? This isn't HTML, this is Java class file. It has to be compiled. So We also have a test. It's going to created a test for us here, right? Which you should be able to see here. And the test is calling this endpoint. If you haven't used Rest Assured, there's some links. I highly recommend that you explore this. It's an absolutely great tool if you're doing any kind of web stuff. When we get this, we expect the name to be hello. Now let's open up a new terminal. Let's make sure I'm in the right directory here. Not J4K. All right, now in this case, I'm going to say clean test. Now this annotation here, Quarkus test, means that this is going to spin up a version of Quarkus. By default, it's going to grab a different port. It's going to grab 8081 by default, which means I can have Quarkus running and spin up another instance of Quarkus to run my tests, which is really nice. And when it gets to one of the pieces that our engineers talked about was developer joy, is make it really easy and really fun to use this product, right? Okay, so here we go. Obviously we failed, right? Because we're expecting hello and we got hello J4K. So that's a problem. So let's come back here. Now the way that we will solve this is let's parameterize this. Let's say config property name equals greeting. String greeting, and we'll come to the application properties and we will say greeting equals, and let's make it a capital J4K. Hello J4K, right? Save that, go back here. All right, capital, so this looks good on our front end. So see, even adding in a properties file, super fast. Now, that's still not going to help our test to pass, right? So let's parameterize this. Let's say dev.greeting. Let's come here and say test.greeting equals hello. All right, so now we're running. We can come back here, run our clean test again, and this time we should pass our test. So we fired up Quarkus, we're at 81, and yep, we have now passed our test. All right, so that's how fast and easy it is to get started using Quarkus. All right, now let's get started on our application. So the specification that Fave Food has given us is right here, right, in our docs. And so it expects us to have a path called /API, right? And then it's going to post an order object that has the properties of customer name, order ID, and Fave Food line items. And then it has a list of line item objects, and the line item objects are going to have properties item, item ID, and quantity. So we need to create that object. And let's come over here to, I thought I changed this, these package names. So let's refactor this package name. Rename package, rename package. I'm going to say org J4K workshops coffee shop. And that is, actually we'll put that in the infrastructure package, right? So keep all our infrastructure stuff there, and our domain stuff will be kept somewhere else. All right, so now we will create a Quarkus Coffee Shop Fave Food domain package, right? And in that package, we will create a Fave Food order. All right, Fave Food order. We are going to have, what do we have? We had a string for order ID, a string for, is it customer name? Let me double check and see. String customer name, yep. And a list of with Fave Food line items, right? Yep, Fave Food line items, right? So obviously we have a problem here because we don't have that object. Let's also create that object in the same package, right? Add that, and that has item, item ID, and quantity. So here we will say string item ID, int quantity. All right, now, a couple of things we're going to do here. We need to create a default empty constructor for JSON-B to marshal this back and forth to JSON. We can also create a constructor with parameters. And let's just give the rest of our stuff here. I like 2 strings, right? That helps us when we're debugging. One thing I wish is that you could just do all these in one, one fell keystroke. But we've now very quickly stubbed out our entity, right? So it's our fave food line items. Let's go down here. All right. Import list Java util. And we'll do the same thing here. Constructor, we need an empty constructor. Okay. And we can make our parameterized constructor. Need a toString method. Yep. And hash code and equals. Yeah, take the defaults there. And getters and setters. Now we can also, okay. Oh, one thing we should do here. Now, this is going to be not so obvious. We're going to type register for reflection on here. We don't need this right now, but one of the features of Quarkus is that we can compile it down to a native binary. To do so, we need to annotate anything that might use reflection with this annotation. So let's annotate that and the fave food line items register for reflection. All right, so now we've got our 2 objects in place. Very nice. Oh, one other thing. Let's come into our application properties where we did this. Let's let's put some really nice debugging levels in here. So I'm going to cheat and just come down and grab my existing resources here. So what we're doing here with this log file, this is just, a format that I like a little bit better. Log level, we're going to set to info, but for anything that's in org J4K, we're going to set that to debug, right? These 2 things we'll use a little bit later. So let's got that in place. Now, let's create a test for this. Really should have started with tests first, right? So J4K, Quarkus Workshop's infrastructure. Quarkus Coffee Shop, let's say, and actually, we're going to leave this test in our main infrastructure package because ultimately we're testing our stuff. So we will say API resource test. Now give it the Quarkus test annotation, right? And we will say at test public test receiving fave food order. All right. Now we can just copy and paste. We'll do a little cheating here. So let's grab this. Of course, there's going to be some changes here. So for starters, let's see when, and this is really nice API here. So we will say when, and we're going to accept media type. Make sure you import the correct types. Media type, JAX RS, application JSON, and content type will be media type, application JSON. And let's say, is it body? We need a string too. So we're going to post JSON. I've got your string you can find in the documentation here. So let's come down here, string JSON. Here we go. We could create JSON a number of different ways. This is just pretty easy though. So we will come do this quickly. We will have all right, so body, and we're going to post, right? We're going to post it. And right now we're just going to say that it's a 202, right? So we expect that we get a 202. All right, now I like to do my testing here at my terminal. Normally I actually do it in a terminal outside of my IDE, but I think this would be easier for the presentation, right? I won't be bouncing around too much. So let's give us our test here. We should fail this test, right? We don't even have this and rest easy hello. So let's say API fave food. That's what we're actually looking for. All right, run that test again. And we should get a 404, right? If this passes, something weird. Okay, we're running an API resource test, and we should fail and get a 404. So we failed and got a 404 as we were expecting. So that's good. Let's close that. Let's come over here. Now we will implement Java class, our API resource. Whoop. All right, so add. So API resource, we're going to say and it's complaining because we don't have any methods yet. So we're going to post, and we're going to say public response because it's expecting a 202. So we have a really easy way to return that. We will say accept fave food order, and we're going to get a fave food order. Let's import response, and let's say response accepted. All right, so we will actually pass our test right now, but we're not actually doing anything. So let's do this. Let's also throw in logger is good, right? So we set up our logging. So we say logger equals logger factory, get logger, API resource class, import logger. So let's say debug fave food order. All right, so we're going to go back to our test, right? We can see that we are getting a response back. So we should actually pass, right? And we should see our logging statement here. Ooh, we didn't pass. Here we go. We will do fave food here because we're probably going to have integrations with numerous different delivery services. Also, keep in mind, we are still running, right? So in my terminal, we're still running. So let's come over here to Postman and take a look at, whoops, where's my localhost, right? So this is in the fave food format, and I'll send this out. And we got back our order, right? And if we look over here, whoops. And if we look over here, we see, maybe I should have chosen a darker screen here, but we see our fave food order, right? So we're logging our fave food order. We've already implemented that. This is really great. Now, of course, we're not actually doing anything. So let's create a test, and let's create our own domain. Let's come down and create our test, and let's say Quarkus Coffee Shop. Now we're going to say new package. We're going to say fave food domain. Now I mentioned domain driven design earlier, which is one of the principles that we want to use here. We want to segment all the fave food stuff behind a fave food package, right? So fave food is just encapsulated. All the functionality for fave food gets encapsulated in the fave food domain. So we're going to implement a fave food order handler, and this will have, we wouldn't have like an order handlers package, right? Everything with fave food goes to fave food, and then we get something else, we'll have something else. So now we will just implement a static method. This is business logic. I don't want to spend too much time. We're not going to do this in a particularly clever way or anything. So if you want to just come down and copy paste this, here's the objects, right? Creating the objects. If you want to just copy and paste this out of this, I don't think that that's really a problem. Although I guess we haven't created the objects yet for our own objects yet. But I'll walk you through. This is the open API spec that we're expecting. Now, in a real world, right, we work for Quarkus Coffee Shop. We would be able to import our jar file, but just to make it easy, we'll just kind of hand tool those objects as if they already existed. So let's say fave food order handler. So now what we are going to do here, I call it fave food line items. Okay, that's all right. So fave food order handler. Okay, we don't have an order in command yet, right? So let's go ahead and create that class order in command. And we were going to, this is going to be part of our actual domain package. So, because this will be this is the format that we're going to add for everything. Now, again, we need to put register for reflection on here. Whoops, register for reflection, clean up that import. And again, if you want, this is where we get this. We have in ours, we're going to have an order object, an order in command, right? So again, in domain driven design, sort of the convention is that we send a command that creates events, right? So this is an order in command. We could also call it create order, whatever. We call it an order in command. It contains a list of beverages and a list of kitchen orders and an ID. And each line item contains an item reference and a name, and the item is an enum, right? Which we, in this case, we could create an enum. We're just going to make it easy and create a set of strings, right? Just do this nice and easy. So if you want to just copy these, you can grab these or you can type them in. Like I said, in a more real world, right, we would just import a domain jar file, right? And then we have a line item also. Let's create a class line item. And if you notice, I'm adding everything to Git. So you can add this to Git and then save this out while you're working. All right, so the fave food order handler test and fave food order handler, feel free to copy paste these. This is really just testing domain logic, which is not a key part of the presentation. So in the order handler, what we have here, this is our order handler test, right? So we just create a fave food order. We create an order in command, expected order in command, and we pass that to our fave food order handler handle order. And then we just make sure that the values have what we think or what we're expecting them to have. The fave food order handler itself also doesn't do very much. It's got a set of beverages and a set of food items. These correspond to the enum that we have here, right? And I mentioned we could have created an enum. We're just going to be very basic here. And obviously there are more elegant ways to translate JSON into Java objects. We're just making this super quick and easy. And we just loop through the line items and translate the format. So feel free to copy and paste these into here, and then you should be able to run your test. Let's see, where's our order handler test? And that should be passing, right? We should be able to run that, and that should give us the expected format that we are looking for. Yep, and we are good to go. Okay, and so the last piece to get the order in, now that we're translating our order, is to implement a REST interface, right? So we've got these pieces on here. So we're going to create a class. All we have to do is create an interface called REST service, and we give it, we tell it to post to the URL we want, right? We're going to use microprofiles REST client, and then we just configure this inside our application properties. So the class itself is very simple. We just have a path we're calling order. We register a REST client, don't forget that, or it won't work. And we have an interface, we're calling ours REST service, and we get a completion stage, which is asynchronous API, and we're getting a response, place orders, final order in command, right? Now, we have to add in the properties for that, give it the URL. Where you can get this URL is from your workshop environment. So mine is coming from right here. Let's go to my topology. Grab the URL from your website and that will be the URL that you'll use right here. I'm still running here. If we can stop that and start that again. So if you want to see, I'm still running this in dev mode. We'll boot this up. My machine's a little bit slow right now. Okay, we're up and running. And then we can come, let's go over where we're using to post stuff. And we can send. Got our name back, that looks good. And let's check our topology, view logs. And the last ordering command sent, black coffee. Scroll over, see who it was for. And it was for Lemmy, which was our person here. If we want to do that again, we can change the name, just check. We'll say, we'll do Spock here. Be sure to change this to 0. And there's Spock. So we got our order in. Whoops, down at the bottom right there. All right, we're ready for part 2. Okay, so let's integrate Kafka into our application. What we're going to do is remove the REST client that we implemented before, and instead of posting to the REST service, we will push the order in command directly onto the Kafka topic, which ultimately is what the web application is doing anyway. So we're just going to bypass that and go directly to Kafka. Now, first things first, we need to open up our POM file and add in the necessary dependencies to work with Kafka. So if you look in the instructions, we've got the dependencies listed right here. So you can just copy and paste these. Those in there. And you might notice we're using something that you may or may not have seen before, or may not have used before, called test containers. This is not a particular Kafka Quarkus thing, but test containers provides ready to go Docker containers for use in testing. And this allows us to spin up Kafka in the background, right? Kafka is kind of a bear to stand up, and there's a number of different approaches for testing. This, I think, is the best one, right? Actually, it spins up a Kafka environment in our background, which is great, and then it allows us to run our tests against that. And then we're also adding in the small-ri reactive messaging Kafka. Small-ri is Red Hat's microprofile implementation. So we're going to use microprofiles reactive messaging here. The next thing we're going to need to do, we just added those in, right? So we'll save and stop. Oh, and if you're using IntelliJ, remember to import, reload your Maven project, right? So we get all those new Maven dependencies inside of our project. The next thing we're going to need to do is add some more configuration into our application.properties, right? We're going to tell the application where to find Kafka, right? So let's come in here and say application properties, and we can get rid of the REST client, so we're not going to use that anymore. So we've got that. Actually, you know what? That'll work for now. Okay. Now, when we test Kafka, what we're going to want to do is we're going to want to create something called a Quarkus Test Resource Lifecycle Manager. And what this does is this is a class that is going to run before our Quarkus tests, and it will take care of background work. In our case, that background work is going to be spinning up a Kafka container that we can then use in our application. So let's come into our test folder here, and just inside here, we'll say new Java class, and we'll call it Kafka Test Helper. We're going to need to implement Quarkus Test Resource Lifecycle Manager. You see IntelliJ doesn't like that, right? So we implement a couple of methods. We only need to implement start and stop here. So what I'm going to want here is private Kafka container equals new Kafka container. It's deprecated, okay, we'll use that right now. And so we'll say here, we're going to say container start, and we will return singleton map, collections singleton map, and we're going to pass in the key of Kafka bootstrap bootstrap servers, and we're going to give it Kafka container get bootstrap servers. And then in stop, we're just going to say Kafka container stop, right? Simple enough. So just to reiterate what this is doing, this is going to spin up a Kafka container. It's going to use the test containers under the cover. It's going to spin up that Kafka container. We'll have an entire Kafka environment ready and waiting for us when we run our tests. So that's really nice. We need to come into our API resource now and tell the class to use it. That's our actual API resource test, and tell our test to use it. We'll say Quarkus test resource, and we'll say Kafka test helper.class. So that means that's all we have to do, right? We created that class, just tells us what to spin up, and we could have added more things in there if we wanted to make it application specific. I made it kind of product specific. We could spin up Mongo in there if we wanted to do Mongo that well, as well. If we wanted to spin up other containers that we built ourselves, like as dependencies, we can do that too. But right now I'm just spinning up this, and so we don't really have to make any changes other than that. It's going to spin up. So now let's add Kafka into our API resource. We need to take out this REST service, right? And I like to code this way. This might drive you nuts. I really hate doing this. They would rather create the class first, but I'm going to say inject Kafka service. And that class doesn't exist yet. And I'm going to say Kafka service place orders. So now I like to just do this and say create class, Kafka service add. I'm going to make this application scoped. And what I'm going to do with this Kafka service, first let's get a logger, right? We always need a logger. Equals logger factory get logger Kafka service class. Okay. Yeah, take that out. I imported the wrong class, so let's import logger. That's left. All right, now we're good. We're going to inject something called an emitter, right? And we're going to inject a channel. Now that channel, if you remember, let's look back at our application properties file. This is defining our channel right here. So it's called messaging outgoing orders, and orders is the name of the channel. It also corresponds with the topic, just because I think that's a nice and neat way to do that. But what we're doing on our Kafka service here is we're going to say emitter, and we're going to emit a string or orders emitter. We'll call it that. We're going to import that. Now we will say public. We're going to do this asynchronously. So I'm going to say completable future void place orders, I think, right? And we'll say final order in command. Let's log it. Logger debug sending to Kafka. We will say orders. One other thing we need to do, we want to send JSON in here. So we're going to construct one other class. So JSONB is what we are using to marshal back and forth in the REST API. So we'll use the same thing. Equals JSON builder create. So now this gives us access to an object that we can say JSON B to JSON order in command. And that's going to, actually we need to return that, don't we? And we need to say to completable future because it's a completion stage. If you haven't checked out Java's asynchronous API, you can spend some time with that. But this is a pretty simple, easy way to do this. But this means it's going to be executed asynchronously. So we can put lots of these in place. It's not going to block while that's running. Microprofile's reactive messaging requires that. We could just call a consumer and block. It's going to be much more performant. And the API is pretty nice. So that's all we have to do for our API resource test. We should be okay to run this. Let's give this a shot here. We're just running inside of our IDE. And I'm hoping that I didn't accidentally boot up Docker while we're doing this. This is taking unusually long amount of time. This kind of took a while. You might even hear my fan spinning, so maybe my hard drive's just on fire. Anyway, so there we go. So our test is running. Now, next we will talk about how we want to see this and get our quick feedback loop and how we want to develop with this, right? But for the moment, we're good. All right, so this is how we fire up Kafka. So we locally using Docker Compose so that we can run our app locally. So inside your terminal, we have inside your solution directory, you'll see two files, Docker Compose and init Mongo. Docker Compose is what we're mostly interested in right now. And what this is going to do is this is going to fire up a Mongo database and an entire Kafka environment for us so that we can run locally. So to do this, just go into your directory. So I'm in the solution directory. So type Docker Compose up. And this will fire up Kafka and fire up Mongo and make them available to us. So we can develop using Quarkus dev. Looks like we're booted. So now let's see what directory we're in here, working directory. So we're in the workshop ls. So now we can say maven clean compile Quarkus dev. We can use our we can use dev mode, and this time we should see it bind, right? Because it knows that we're talking to Quarkus. We should see it bind to Quarkus here. I mean, bind to Kafka. And it takes a second for it to run. So there we go. And that's what we're looking at here. So this is our small RI reactive messaging provider. I've got my format. The format that I pasted into there just uses an abbreviated syntax for the class files. And we found the incoming and outgoing connectors and we merged that configuration. So our application is running. And if we want to go to post something, right? So we're going to post to localhost 8080 API fave food. We can send this over. And we can wait for our computer to struggle under the amount of resources it's taking to record this. There we go. So we're sending our order in command. So everything's sent and work kicked off nice, and there is the response that we expected. All right, so now we're running locally. We've got Kafka running, and we've learned how to test that as well. So we can spin up Docker in the background, run our tests. We can spin up Docker locally and work with Quarkus in dev mode. You can't do both of these at the same time, though, because you can end up with all kinds of Docker port conflicts. All right, let's get ready for our next piece. Okay, so in this part of the workshop, we're going to add in persistence with MongoDB. And it doesn't really matter what database we're using. I like using MongoDB. It's pretty easy to use. It also, I think, dovetails really nicely with using JSON. Yeah, surprise, surprise. I'm not exactly alone in that sentiment. And since we are using JSON for our events, I think it's a really great way to do persistence. It makes it a lot easier. Now, we're also going to use Hibernate Panache. And honestly, our use case is really simple here. So it's not a big deal, but Panache is really worth checking out. It's a big advantage on top of what Hibernate typically brings to the table, or what you're used to Hibernate bringing to the table. So let's add in our dependencies. So we're going to add in our dependencies, which you can get from the tutorial, and go back over here, pull up our POM file. You might notice it might be driving you nuts that I'm not really organizing these. I typically organize these. I put all my tests and stuff in one section, my database things together. We're just going quickly here, so I'm not going to do that. But just copy and paste those in, and be sure to import these. If you need to import them into your IDE, just so it picks up your changes to your class path. And now the next step we also need to add in our database connection string, right? And again, just copy and paste this stuff. There's no way to memorize database connection stuff. And come over to our resources, our application properties, and we will paste data source in here, right? Pretty basic data source, database stuff. Now, what we're gonna persist is our fave food order, right? So we go into our fave food domain. Oops, where's our fave food order. And we are now going to, if you notice here, we're going to extend Panache Mongo entity. So we're going to say extends Panache Mongo entity. And we're done changing our domain class. We're going to create one more thing here. We're going to say fave food will create an infrastructure package. And inside there, we will create a new fave food order repository. Now, in Hibernate Panache, you can use an active record pattern, so we could have the entity persist itself, or we can use a repository. I like using a repository because I think it makes testing easier. I think it's a little bit cleaner, but feel free to take either approach you like. What the repository we have to do is we have to say implements Panache Mongo repository fave food order. And that's it. We're done, right? So that's complete. Come into our API. We get a ton of different functionality from that. Now we'll take a look here. So we've got our Kafka service. Oh, I am going to need to make that application scoped so that we can inject it, right? So let's come back here. Let's say application scoped. Yep. And we're going to inject our Kafka service. We will also inject repository. Now, I mentioned that you can get all kinds of stuff here, right? So let's say repository. We're just going to say repository persist and call fave food order, right? And that's all we have to do to persist this order. There's all kinds of other methods that we get off of this. Expand this a little bit. Feel free to play around here and see what we get. We can get count, so we can find out how many records we have. We can delete documents, delete all, find by ID. We can write queries in here, so you can, like, if you're looking for stuff. But building out REST applications, this is Panache is super useful. We're not doing, like I said, we're really not doing all that much with it at the moment. Now, for our test, our API resource test, we're going to need to do something a little funny. And this is the piece that the other thing that we imported here. We've got that in there. We're going to need to, inject mock. All right, so what that's going to do, this is going to mock out the object for us so we can run our test and it won't cause a problem. So let's run our test really quickly here. And this is just going to put a mock in place, which means we're not going to have to worry about actually spinning up and connecting to our database, because we're not going to be able to connect until we fire up Docker Compose again, because Docker Compose will have that running. So let's fire up and test. If you can hear my fan spinning, my computer's running pretty a little bit slow at the moment. So this is taking a second, just like that last test we recorded. But here we go. And we're good, right? So our test all worked. Now let's go to our terminal. And this was the directory where we have our Docker Compose. If you skipped around, I'll go back to that. So inside our solution, you have an init Mongo.js and a Docker Compose YAML file. So if you are inside your terminal and you're in the workshop directory, actually, I give you the workshop solution directory, don't I? Yeah, wrong. Be in this one. Oh, it's actually still running. Okay, so I am currently running it. I am currently running, so we can come in here and just fire up Maven clean compile Quarkus dev. And we can, we'll see this fire up. We should be able to connect. We'll see our connections getting made to Kafka. We saw that. Okay. So now let's do this. We'll come back to our post thing. We will make a post. Oh, one thing to remember to do if you're doing multiple ones of these, change at least something here, because Once we're sticking these in the database, we'll get an error if we send the same thing in over and over. Okay, so that looks pretty good right here. What do we have? You know what? We didn't put any test. We didn't put a log statement saying that we're persisting that object. That's okay. Let's go to MongoDB Compass is a visual tool that Mongo provides. We'll fire that up, and let's come back to our application properties. Whoops. Our application properties file to get our connection string. And using Compass, we can't use this exact connection string. The user here needs to be changed to admin, right? So, and we can connect. And there's our database. We've got a fave food order, which we just sent in, and there's Lemmy with our fave food order. There's the 8 that we changed from 9, right? So we're persisting orders into our database, right? We've round trip now. So now we're ready to push, we're ready to roll to production.